Hello friends, good afternoon and welcome to our session of Slope Deflection Method. Welcome to our channel Genius Structures. I am your host Dr. Suman Kulkarni, and today we shall solve one portal frame which involves three unknowns, and it is also involving the additional degree of freedom which is sway. So we have already seen how to identify a sway type of portal frame. Today we shall solve actually the portal frame. Okay, so this is one single story frame which is satisfying two criteria of a sway type of portal frame. First is column heights are different. Second, I values are different. Cross-sectional area of both the columns is different. So this is a sway type of portal frame. Hence, the additional unknown displacement quantity is delta. Okay, and here we have to solve or find three unknowns. One is rotation of B, another is rotation of C, and third is sway of the column. We are assuming this frame to sway towards right, which will be assumed positive, and this delta will be 0 for the beams, and delta is only there for columns. Okay, so keeping in mind these assumptions, we will now solve ahead for this frame. Okay, so let us start. So our second step will be fixed end moments. Okay, fixed end moments. So what will be fixed end moments? Very simple. We have columns with zero external loading. So MFAB, MFBA and MFCD, MFDC. These four fixed end moments will be 0. So there will be only one pair of fixed end moments, that will be for beam BC. So MFBC, what will be MFBC? Minus WL square upon 12. And answer for this, minus 12 into phi square upon 12. Okay. So answer is phi square. So minus 25 kilonewton meter. And MFCB is plus 25 kilonewton. Simple. So now we have finished with our step number 2. Next will be step number 3. What will be step 3? Slope deflection equations. This is a little bit lengthy. So let us now form six equations which are slope deflection equations. So MAB will be first. So 2EI by L into bracket 2 theta A plus theta B minus 3 delta by L minus MFAB. This is our equation. For column AB, I value is 3I. So 2E into 3I upon 3 into bracket. Theta A is 0 because support A is fixed. Theta B is unknown. Minus 3 delta by 3. MFAB 0. Correct? MFAB 0. So simplify this. So this 3 gets cancelled. So 2EI into theta B. So 2EI theta B minus 2EI delta. First equation is over. 2EI theta B minus 2EI delta. Correct. Now MBA. What is MBA? 2EI by L into bracket theta A plus 2 theta B minus 3 delta by L plus MF BA. Okay, so again 2E into 3I upon 3 into bracket theta A 0, then 2 theta B minus 3 delta by 3 and MF BA again 0. So this will be 2 into 2 4. This 3 again gets cancelled. So 2 into 2 4. 4 EI theta B minus 2 EI delta. Correct? This 3 again gets cancelled. So 2 EI delta. So one pair is over. Now come to second, MBC. What is MBC? 2 EI by L into bracket 2 theta B plus theta C minus 3 delta by L minus MFBC. Now as per as our assumption, delta for beams is 0. So this term will not be there. Then I value for beam 5I. So 2E into 5I upon 5 into bracket 2 theta B plus theta C. Do we have any MFBC value? Yes, minus 25. So now this 5 again gets cancelled here. So 2EI into 2, 4 EI theta B. Okay, 4 EI theta B plus 2 EI theta C minus 25. Okay, MBC is over. Now MCB. What will be MCB? 2 EI upon L into bracket theta B plus 2 theta C minus 3 delta by L plus MFCB. So again substitute the values. 2E into 5I upon 5 into bracket theta B plus 2 theta C plus 25. Simplify this now. So we will get 2 EI theta B plus 4 EI theta C plus 25. Okay, so 4 equations are over. Let us get to the next pair, the last pair of equations. Now I will rub this. So now MCD. Okay, MCD. MCD is 2 EI by L into bracket 2 theta C plus theta D minus 3 delta by L minus MFCD. So I value for CD column is 4I. So 2E into 4I upon 4 into bracket 2 theta C plus theta D. Theta D is 0. So minus 3 delta by L or 3 delta by 4 minus do we have any fixed end moment for column CD? No. So we will simplify this now. This 4 gets cancelled. So 2 EI into 2 theta C. 4 EI theta C. Okay. 4 EI theta C. This 2 EI into 3 delta by 4. So it will be minus 3 EI delta by 2. Minus 3 EI delta by 2. Yes. Now MDC. MDC, again write the complete equation first. 2 EI by L into bracket theta C plus 2 theta D minus 3 delta by L plus MFDC. So 2E into 4I upon 4 into bracket theta C plus 2 theta D is not there. So minus 3 delta by 4. This one is 0. So 2 EI theta C minus 3 EI delta upon 2. Yes. So these are our 6 equations. Now we have to find our unknowns. Before that, we have to go for equilibrium equations. So step number 4. I will just rub this part. Okay. So step number 4, equilibrium equations. So equilibrium equations are 3. One will be on joint B. So at B, what will be your equation? MBA plus MBC, it is equal to 0. Now what is MBA? This one. What is MBC? This one. So add these two. So 4EI theta B is 2 times. So this becomes 8EI theta B. Okay. 8EI theta B plus 2EI theta C minus 2EI delta minus 25 is equal to 0. Bring this on right hand side, it will become plus 25. So this is our equation 1. Okay. Second condition of equilibrium will be on joint C. So MCB plus MCD, it is equal to 0. Now what is MCB? This equation. What is MCD? Here. So 2EI theta C, let me rewrite this. This is theta B. Okay. Yes. So 2EI theta B plus this 4 and this 4, 8EI theta C, then plus 25. Before that, this term, which is 3 by 2 means minus 1.5 EI delta, it is equal to minus 25. So this is equation 2. So we have 3 unknowns. We have got 2 equations from 2 conditions. We need one more equation of equilibrium, which will be from shear equation. So how to get that shear equation? Let us see. Now I will rub this part. I'll rub everything. Okay. Now what we will do is, we will take free body diagram for columns A, B and C, D. Then we will go for finding out horizontal reactions on A and D. Okay. So this is, we shall assume MAB anti-clockwise. Here MBA again anti-clockwise, and this is HA 3 meter, and here we are going to take summation of movement about B. So we will get HA into 3 minus MAB minus MBA, it is equal to 0. So what will be HA? MAB plus MBA totally divided by 3. Then free body diagram for CD column. So here is D, here is C. No, C is on top, D is at the bottom. We have to find HD. 4 meter is the height. This is MCD. This is anti-clockwise, we have to assume. So MDC. Here also now again we will take summation of moment about C. So HD we will get as MCD plus MDC totally divided by 4. Now we will consider the complete frame. So summation Fx is equal to 0 for whole frame. Okay, this is what we are going to apply for the whole frame, summation Fx. So HA plus HD is equal to 0. There is no external horizontal force on the frame. So what is HA? MAB plus MBA totally divided by 3 plus MCD plus MDC totally divided by 4. This is equal to 0. And now we are going to substitute here 4 moment values from the previous step. Then we shall simplify this and we will make or bring our third equation of equilibrium. Then we shall solve our 3 equations of equilibrium simultaneously and we will get our 3 unknowns. Now by substituting all the values of moments which are calculated in step number 3, I have framed third equation of equilibrium which comes as 24 EI theta B plus 18 EI theta C minus 25 EI delta. It is equal to 0. Now we have to solve equations 1, 2 and 3 simultaneously. So make use of engineering calculator appropriately, enter correct values and solve it on calc. You will get EI theta B as 4.47, EI theta C minus 3.97, EI delta 1.44. After getting these unknown displacement quantities, again go back to step number 3, slope deflection equations. Substitute there these 3 values one by one along with their signs and get the final moments. MAB 6.06 kilonewton meter, MBA 15.06, MBC minus 15.06, MCB 18.06, MCD minus 18.06 and MDC 10.01. So I have shown all these 6 values in the frame along with their directions in red color. Now since columns are not subjected to any external loading, so there will not be any points of zero shear force, but the beam is subjected to UDL. So we will have to first of all locate point of zero shear force. There the moment will be maximum. That moment we will find out, and then we will draw the deformed shape of the frame, and then finally we shall draw the BMD for the frame. Now we shall proceed towards drawing bending moment diagram for this particular frame. So as I told you previously, columns will not have any zero shear force, beam will have. So I have taken free body diagram of beam. Here I have shown the final moments: 15.06 anti-clockwise, 18.06 clockwise, 12 kilonewton meter external UDL, 5 meter span, and these 2 reactions. So first of all I will find out these 2 reactions. I have taken summation of moment about B and I have written the equation for moment: minus RC into 5 plus 18.06 plus 12 into 5 square by 2 minus 15.06. It is equal to 0. Now from this equation I will get RC is equal to 30.71 kilonewton, this reaction. For this frame again I have applied summation of Fy is equal to 0 and I have got RB, reaction on B, as 29.29 kilonewton. Now for this particular beam I have drawn shear force diagram. If you see here, 29.29 is the ordinate here, 30.71 is the ordinate here. So I have to find this x distance. This is the point of zero shear force. So using similarity of triangles, I have found x as 2.44 meter and I have taken this section, and for this free body diagram at this particular section again I have taken moment. So that moment must be positive because it will be maximum moment. and it is on point of zero shear force. Hence, this moment is 20.69 kilonewton meter. Now, I have shown all these moments except this one here. Okay. So for this diagram, along with this moment, I have drawn now the deformed shape of the beam. The frame, and wherever the members deform on those particular sides, I have plotted bending moment ordinate values. So this is our BMD on tension side, 6.06 clockwise, deformation on right hand side of the column, hence value is on right hand side. 15.06, this value clockwise rotation or moment, deformation is on clockwise left hand side, so moment or value plotted on left hand side of the column. For beam, this is anti-clockwise moment, rotation above, so value is plotted above the beam. Here value is clockwise 20.69, it is going to deform the beam below, hence 20.69 is plotted below at a distance of 2.44 meter from end B. Okay, then this end is going up, so value is 18.06 above the beam. Here 18.06 is anti-clockwise, so on the right hand side the deformation of the column is there, hence value is on right hand side of the column. Last one is anti-clockwise moment of 10 kilonewton meter, 10.01 precisely, so it is on left hand side of the column. So this is our BMD on tension side. So friends, this is my analysis on this particular portal frame, so a type of portal frame. If you have any difficulties, do ask, and if you like the video, do subscribe the channel and hit the bell icon. Thank you very much.